Here's a nice and simple linear algebra problem that I discovered in the context of a math contest. It asks, is this 11 by 11 matrix invertible? So I highly encourage you to try this yourself. But doing simple problems like these, or even just thinking about them and trying to struggle with them, can sharpen your intuition for linear algebra or matrices in a fun way. You don't necessarily have to make progress, but testing ideas can help you learn a lot more without even solving the problem. So, for example, we could try calculating the determinant of this, but maybe we realize pretty quickly that calculating a determinant of an 11 by 11 would be an absolute nightmare. Maybe there's some way of simplifying it. But there's another condition that we can use to check for invertibility. In particular, we would need to show that all of the rows or the columns are linearly independent. And it seems like maybe we can disprove this by using this pattern of how the rows are constructed. So by fiddling around with it, we can see fairly simply that no row seems to be a multiple of any other row. So at first glance, it might seem like they're all linearly independent. However, if we look at, for example, the second row minus the first row, then we get all 11s. And from here, it might be obvious that if we take the third row minus the second row, we'll also get all 11s. So in fact, by taking row 2 minus row 1 and subtracting row 3 minus row 2, we get 0. And this is actually a non-trivial linear combination of the rows, which gives us 0. So the matrix is not invertible.